I would like to demonstrate the exciting new Precigeo solar layout tool. This tool will revolutionize the solar sales process with one-step design and sales presentation. All you need to start is to give us an address. The tool will enable you to lay out modules and design solar electric systems without visiting the site. In addition to seeing the monthly solar access, you'll be able to test different designs and know the kilowatt hours per square meter for each roof face, and determine kilowatt-hour production once you have your design in place, and demonstrate the value of the made kilowatt-hours by setting an energy cost default. Let's start. Enter the ID. The house you ordered will appear. As you see, this is an annual insolation map with the kilowatt-hours per square meter detailed in insolation or sun hours, which is irradiance over time. You can see through the entire year, and you will be able to make the best determinations about where modules belong and where they don't, and be able to communicate that to the homeowner or business owner, while simultaneously designing the highest performing system possible. Now, this is a high-resolution overhead image, which makes it easy to explain to a homeowner the relationship between shading and insulation. The modules we have supplied you can identify by clicking the I button. We will go down to the bottom of the page where you will find links to string calculators and the ready-to-go modules we supply. From left to right, we have Trina, Sharp, Kyocera, Evergreen, Sanyo, SunPower, SunTech, BP Solar, Solar World, and Mitsubishi. Now as well, you can make your own modules. So I put the module number and manufacturer model designations. Then we enter the width and the height of the module, and if you desire a margin in between modules, or the clamp systems. The method we have adopted at Precigeo is to input the module's STC rating and use the PV watts DC to AC derate factor of 0.77. If you use those numbers, the power output from your system will be in sync with PV watts version 1 and 2 and other calculators around the country, such as the CSI EPBB. You can move the modules around by just grabbing them. You can put them in landscape or portrait mode. As you can see, the modules scale and align automatically and give their own individual insolation, solar access, and kilowatt-hour information as they are moved from one location to another. The module's data is retrieved from the data points, which are an active layer in the tool. To make compliance with the CAL FIRE document easy, we created an edge offset tool. You can put the modules on the roof in such a way that it is possible to get the correct placement of the modules right from the start without spending a lot of time. You want 3 feet from the ridges, hips, and valleys. Some very strict authorities require a 3-foot setback from the eaves as well. This is rare, so in this demo we are putting modules right up to the eaves, which is fine. We're now going to place 2 strings or groups of 9 panels, one facing southwest and the other facing southeast. We will unify each panel in the string. We will also be able to visit a string calculator to verify that the design works electronically. We'll be able to access information about each individual module, and we can also look at information on all panels combined, as if we were in an N-phase style setting. We have as a system total 5,421 kilowatt hours. If all of the 18 modules were using N-phase inverters, it is good to make a check of individual panels to seek out any outliers, which may indicate that a DC to DC power conditioner could be helpful. And when we do add the panels to strings, we want to keep in mind that the performance will be based on a multiple of the weakest panel in the string. All of these capabilities and insights will help answer questions during the sales process. Questions regarding microinverters, power conditioners, solar edge inverting systems, conventional string inverters such as SMA, Fronius. Having the answers to questions and concerns immediately available will facilitate your sales process. Here we have the panel, the Trina 230-watt polycrystal. We are in Santa Clara, California, so we will select 32 degrees as the lowest temperature. We'll put ourselves in the 4800-watt inverter and see if the 2 strings of 9 is an acceptable recommended system for PV power. Looks like we're in good shape. We will print this for our engineering department, and for our own records, the continuous amperage, the STC, PTC, and AC power ratings. We'll go back to the tool. Let's go ahead and assume you are going to practice this and design in front of the customer. They're going to be impressed. Their trust in you is going to be high, and you will be designing a system and not have to go back and forth with your engineers with the design iterations based on module placement and string lengths, etc. No surprise change orders and installation delays, no tape measures, no ladders, no climbing, just designing the best performance systems possible for each site and make the sales presentation on your first visit, while increasing your customer's confidence rate and your close rates as well. Let's go ahead now and combine these 9 southeast-facing modules into a string. We'll go to the Select tool and left-click while holding the Shift key down. We can add all other modules by left-clicking them in. We will see that the string production, once all the panels are unified in a string, will be 2704 kilowatt hours, and that for the panel-wise, or all panels on their own, as if they were in an N-phase system, will be 2763, so there is a slight difference between the designs and an important consideration when designing and answering the questions from a customer. So with string 2, we will absolutely take the same steps. To create string 2, we'll start clicking on the modules and holding Shift and left-clicking them. We'll add them all to the string. We will see that string 2 will make 2623 kilowatt hours, while string 1 was 2704. We can see which string is best, and adding these 2 strings together, we can compare the complete or total string-wise summation to the entire panel-wise summation, like an N-phase style system. Precigeo Solar Design Tool will help you answer questions with correct answers immediately during the sales and design process, and keep the momentum moving forward without interruptions or needless distractions. With this tool, you'll be able to design and present and sell the highest performance systems quickly, without change orders or any other confusion. To summarize, what we are trying to do is supply you with the science and tools to be a superior solar sales and design consultant, and make more effective presentations, see more clients, and close a higher percentage of your quotes. Let's take a final look at the house with the modules on the high-resolution overhead picture, and then print the system design on the annual insolation map for the client. Thank you very much from Precigeo, and we hope to see you at our website very soon.